Okay, I always say okay when I start. This video is going to be the solutions to your Chapter 10 review. Chapter 10, the first half was gas laws. Um, the second half dealt with diffusion and effusion of gases and Graham's law. Okay, so we'll cover both, and let's get it rolling. Okay, easy question. The main component of air is nitrogen. Air is 80% nitrogen and roughly 20% oxygen. That adds up to 100. In actuality, 79.9, 19.8, and it might vary in some aspects. Everything else is about 0.3%. But everyone should know that air is mainly made up of nitrogen, which is an inert gas. It doesn't react. Of the following, what is characteristic of gases? Well, gases are highly compressible, and this has to speak of kinetic theory. The relatively large distance between them, that's true. And gases form homogeneous mixtures regardless of non-reacting gas components. And a gas will spontaneously fill its container. So that points to all those things being true. The first person to investigate the relationship between pressure and volume and found out that pressure times volume is equal to a constant, or P1 V1 equals P2 V2, and that's Robert Boyle. D. Okay, and now we get into some gas law type problems. The gases initially, pressure is 4 atms, and it's compressed from a volume of 8 liters, and then it goes at constant temperature, so temperature is not a factor, and to the final volume of 2 liters, so 1 and 2, and the question is, what's your pressure in ATM? The 24.2 was never a factor. Moles never changed, so that same amount of grams is there. And this problem is a Boyle's law problem. P1 V1 equals P2 V2. So my solution in the equation is going to be solve for P2. P2 is going to equal P1 times V1 over V2. So it's going to be 4 times 8 divided by 2. So 8 times 2 is 16.0 ATMs. You decreased your volume, so your pressure went up to 16. Your volume went down by a factor of 4, your pressure went up by a factor of 4. A balloon originally, number 5, had a volume of 4.39. I'm always going to start by writing down all my factors. Temperature is 44. I'm always going to add 273 to that right away. I get 317. Always check me on my math. I do make mistakes, and I'm just doing this live. Pressure equals 729 torr. Okay, the balloon must be cooled to, okay, they're going to trick you. They want to reduce the volume to 3.78 liters. So that's going to be 2, and we got 111. Temperature 2 equals, well, you're going to solve for the temperature in Kelvin, but the trick is they ask you temperature in Celsius. And they now say it's constant pressure, so pressure 2 equals 729, so I can just forget about pressure. Okay, the gas law I'm looking for is Charles's law. V1 over T1 equals V2 over T2, and I want to solve for T2. I would invert the equation, so I would say T1 over V1 equals T2 over V2. Solve for T2. T2 equals T1 divided by V1. That should be 1 good. And then times, multiply both sides by V2 to solve for T2. So I'm going to take my 317K multiply it by the second volume, 3.78. I'm going to divide it by the first volume, 4.39. And here's the part where they're going to try and trick you. I would not do this to you on a test. 317 times 3.78 divided by 4.39. In Kelvin, your answer is 273 K, but to convert that back to Celsius, the answer is 0 degrees Celsius. And if you fell victim to that trick, the trick was the units we're looking for is Celsius. So you might have saw your answer is 273 K, but that's 0 degrees Celsius. Okay, what do we have here? I said okay again. This gas has N equals 3.21 moles. The volume equals 56.2 liters. Temperature is 44 again, so 44 was 317 K. And pressure, they're giving me everything here, 793 torr. Now they changed the moles to 5.29. So now I have a second mole, so it's 1, 1, 1, 1. How many liters does it occupy? So the answer is V2. And very trickily, they say under these conditions, which means T1 is still 317, P1 is still 793. Those are those conditions, so we can consider those to be constants. Okay? And the gas law that I'm looking for would come from the universal gas law. Now, I would say P1 V1 over T1 equals P2 V2 over T2. But if I'm going to put moles into this, moles ends up on the bottom, 2. And then in this case, pressure and temperature were constant. So my equation is V1 over N1 equals V2 over N2. Solving for V2, I'm multiplying both sides by N2, and there's my equation. So V2 would equal N2, 5.29 moles, times V1, 56.2 liters, divided by N1, 3.21. Moles cancels out, and the answer will be in liters. I always want to check that they never play games with me, that they don't change your units to milliliters or anything different. 5.29 times 56.2 divided by 3.21, and my answer is 92.6. D. Let's keep rolling. So, pretty much your test is going to be on like the first 12 problems. I'm just going to go with straight up gas laws and not pull any punches. All right. The gas originally, let's see, I want to make sure I'm in the image. Okay, is at 27 degrees, so my temperature is 27. I'm going to add 273 to that, and that's nice and round. That's 300 degrees Kelvin. The pressure is 1 atm, and the volume is 3.9. So they're just using 2 sig figs. This gas is cooled at a constant pressure. Now, as soon as they say constant pressure, I can just forget about pressure. It hasn't changed. Cool it to 11 degrees. So now I got T2, and it makes this a 1 and a 1. So 11 plus 273 equals 284 K. And what's the new volume? What's the V2? Liters. Okay. Charles's law. So what I'm looking for is V1 over T1 equals V2 over T2. Solving for V2, I'm going to multiply both sides by the T2. There's my equation, and now I'm just going to plug in the numbers. It's a great way to do problems. V2 equals T2, 284K, times V1, 3.9 liters, divided by 300. Okay. Alright, so I got 284 times 3.9 divided by 300. And the answer is 3.7 liters. One thing about gas laws, the way of doing gas law problems has not changed. I mean, technically you could sit here and say that it's a ratio. It is a ratio. That's what these are. And you could actually look at gas laws like in a dimensional analysis, but there's no sense to make it complicated. It just works with your equations, and it's not that bad. Okay, sample of gas is originally at 25 degrees, so temperature equals 298 Kelvin. That's that plus 273. Okay, pressure is 1 atm, and all I do is I create a list. Volume is 2.5 liters. Okay, and is allowed to expand until the pressure. Okay, so now we have a new pressure. Pressure 2 is 0.85 atms. As soon as I knew a new pressure, I say these are all 111. Okay, the temperature is 15, so T2 equals 15 plus 273, and that would be 288. Okay, and what's your final volume? Liters. So it's the combined gas law. P1 V1 over T1, P2 V2 over T2. All your variables in there. It's not you don't need moles because moles is constant. I'm going to solve for V2, so I'll divide by P2 and I'll multiply by T2. So multiplying by T2, dividing by P2. Plug all my numbers in. V2 equals, okay, P1 V1, so it's 1 atm times 2.5 liters divided by 298K. That would be P1 V1 T1, and now I'm going to multiply it by P2, 0.85 atms. I'm going to divide it by, did I do that right? No, I didn't do that right. Bad eyesight. The 0.85 is on the bottom. I want to divide it by the pressure and correct that. I want to multiply that by the temperature, which is T2 is 288. Okay. Alright, so what do I got? I got 1 times 25, 2.5 times 288 divided by 298 divided by 0.85. Answer 2.8 liters. Check. If you're doing a worksheet like this, you should have all your work shown. Okay. If you don't feel comfortable filling it out on this, just pull out a notebook and do all your work in a notebook. Okay. The pressure of a sample of methane gas, number 9. Okay, I have a temperature and I want the pressure. They're not really changing that grams at all, so the moles is constant. So I have a volume of 30 liters and a temperature of 402. That's 1 and 1. I want to know yeah, I do have a problem. Okay, didn't read it carefully. I want to know the pressure, and the pressure is question mark atms. And yeah, that 6.02 is going to mean something because this means I only have one set of conditions, so I'm going to use PV equals nRT. I want to find the pressure, so P equals nRT over volume. Okay. The problem is I don't have moles just yet. The R I'm going to use, because I'm an ATM, is 0.0821 ATM per liter, per mole, per K. Throw all those units in there. I'm to write really small. Temperature is 402. So the K cancels out. Then I'm going to divide that by the volume, and the volume is 30 liters. So now liters cancels out. And I have to take methane and convert 6.022 grams of methane, CH4, to moles. So that's a little bit, just a little bit of dimensional analysis. Grams to moles, I need the molar mass of methane, which is 16 to 1. CH4, carbon is 1 times 12 is 12. Hydrogen is 4 times 1 is 4. So methane is 16.0 grams per mole. So I'm going to take 6.022 divided by 16, and the number of moles equals, right after it, 0.376. They gave me 4 sig figs. I'm going to end up cutting it down to 3, so I'm happy with that. So I put in 0.376. Now I'm going to multiply that by 0.0821, multiply it by 402, and divide it by 30. And that should give me my pressure, and pressure should equal 0.414 ATMs. C. The thing I should write down is my R. Because I was looking for ATMs, I chose 0.0821. R always depends on the pressure you use. If you have Kelvin, if you have a torr or millimeters, you would use 62.4. And if you had kPa, you would be using 8.314. We end up using 8.314 anytime we do energy problems, and that'll come up later. Okay, the pressure exerted by N equals, now N's going to start becoming important to us. I got a feeling they're going to throw more PV equals nRT problems at us. Volume equals 13 liters. And the situation here is just always create a list. Very easy to be consistent with that. Always add 273. So we got 295K. And the pressure equals question mark ATMs. Since I'm using ATMs, the R I want to use is 0.0821 ATM per liter per mole per K. And again, there's only one set of conditions, so I'm using PV equals nRT. I want to solve for pressure, so I divide both sides by V. And pressure equals nRT divided by V. So N is 1.3 moles. R is 0.0821. I won't throw all the units in. Temperature is 295K. And divided by 13 liters. So I got 1.3 divided by 0.0821 times 295 divided by 13. And the answer is 359. And had to do something wrong, so let me run that through again. 1.3 times 0.0821 times 295 divided by 13. 2.42. So just 2.4 ATMs. Because the volume had 2 sig figs in it. Okay. What's the molar volume at STP? Everyone should know, 22.4. Standard temperature and pressure. Okay. We've been looking at this for a long time. Temp is always 273K. Pressure is 1 ATM. I could also look at that as being standard temperature is 0 degrees Celsius and 760 millimeters HJ. And so we got 273K and 1 ATM fits. Okay, good. All right. And now we're coming up on some partial pressure problems. Okay, and Dalton's law. The pressure in a volume equals I'll make use of this space. Volume equals 12.2 liters. What I contain is I got 2.34 grams of carbon dioxide, CO2. Okay, 1.73 grams of sulfur dioxide, SO2, and 3.33 grams of argon. Whenever you see grams, you're always going to convert right away to moles. So gram per mole, and gram per mole. Okay. CO2, the molar mass is 44 to 1. SO2 is 32 plus 32 is 64 grams per 1 mole. And if you catch me off balance, just want to check. Argon's 40 to 1. Okay, so I'm going to take all my masses, 2.34 divided by 44, and end up with 0.053 2 moles of CO2. Okay, 1.73 divided by 64, 0.027 moles of SO2. And argon, 3.33 divided by 40 is 0.08 325 or 3332 moles of argon. Okay. What do I want to know? Well, the temperature is 42 degrees Celsius, so I'm going to add 273, and I get 315K. And I want to know what the total pressure is in millimeters of mercury. So what I'm going to use, the one thing about it is they want the pressure in this container. Well, I have to add up all these moles. So this is going to be moles total equals moles of CO2 plus moles of SO2 plus moles of argon. I could figure out the pressure of each individual gas. That's a lot more work. I can just total up all the moles and say what's the total of the moles. And the R I'm going to use has to be 62.4 millimeters Hg per liter per mole per Kelvin, because it's in millimeters, not atmospheres. So I have PV equals nRT. I'm solving for P. So P equals nRT over V. Big question is what's N? 0.0532, the carbon dioxide, added to 0.027, the SO2, plus 0.0832, and the answer is 0.163 moles total. So my answer is 0.163 moles times 62.4 times the temperature, 315 K. All the units will end up canceling out except for millimeters Hg. So your pressure, then you're dividing it by the volume, which is 12.2 liters. So times 62.4